Technical debt is a neologistic metaphor referring to the eventual consequences of poor system design, software architecture or software development within a code base. The debt can be thought of as work that needs to be done before a particular job can be considered complete or proper. If the debt is not repaid, then it will keep on accumulating interest, making it hard to implement changes later on. Unaddressed technical debt increases software entropy. As a change is started on a code base, there is often the need to make other coordinated changes at the same time in other parts of the code base or documentation. The other required, but uncompleted changes, are considered debt that must be paid at some point in the future. Just like financial debt, these uncompleted changes incur interest on top of interest, making it cumbersome to build a project. Although the term is used in software development primarily, it can also be applied to other professions. Common causes of technical debt include business pressures, where the business considers getting something released sooner before all of the necessary changes are complete, builds up technical debt comprising those uncompleted changes. Lack of process or understanding, where businesses are blind to the concept of technical debt, and make decisions without considering the implications. Lack of building loosely coupled components, where functions are not modular, the software is not flexible enough to adapt to changes in business needs. Lack of test suite, which encourages quick and risky band-aids to fix bugs. Lack of documentation, where code is created without necessary supporting documentation. That work to create the supporting documentation represents a debt that must be paid. Lack of collaboration, where knowledge isn't shared around the organization and business efficiency suffers, or junior developers are not properly mentored. Parallel development at the same time on two or more branches can cause the buildup of technical debt because of the work that will eventually be required to merge the changes into a single source base. The more changes that are done in isolation, the more debt that is piled up. Delayed refactoring. As the requirements for a project evolve, it may become clear that parts of the code have become unwieldy and must be refactored in order to support future requirements. The longer that refactoring is delayed, and the more code is written to use the current form, the more debt that piles up that must be paid at the time the refactoring is finally done. Lack of knowledge, when the developer simply doesn't know how to write elegant code. Consequences. Interest payments are both in the necessary local maintenance and the absence of maintenance by other users of the project. Ongoing development in the upstream project can increase the cost of paying off the debt in the future. One pays off the debt by simply completing the uncompleted work. The buildup of technical debt is a major cause for projects to miss deadlines. It is difficult to estimate exactly how much work is necessary to pay off the debt. For each change that is initiated, an uncertain amount of uncompleted work is committed to the project. The deadline is missed when the project realizes that there is more uncompleted work than there is time to complete it in. To have predictable release schedules, a development team should limit the amount of work in progress in order to keep the amount of uncompleted work small at all times. As an evolving program is continually changed, its complexity, reflecting deteriorating structure, increases unless work is done to maintain or reduce it. Manny Lehman, 1980. While Manny Lehman's law already indicated that evolving programs continually add to their complexity and deteriorating structure unless work is done to maintain it, Ward Cunningham first drew the comparison between technical complexity and debt in a 1992 experience report. Shipping first-time code is like going into debt. A little debt speeds development so long as it is paid back promptly with a rewrite. The danger occurs when the debt is not repaid. Every minute spent on not quite right code counts as interest on that debt. Entire engineering organizations can be brought to a standstill under the debt load of an unconsolidated implementation, object-oriented or otherwise. Ward Cunningham, 1992. In his 2004 text, Refactoring to Patterns, Joshua Karivsky presents a comparable argument concerning the costs associated with architectural negligence, which he describes as design debt. Activities that might be postponed include documentation, writing tests, attending to TODO comments and tackling compiler and static code analysis warnings. Other instances of technical debt include knowledge that isn't shared around the organization and code that is too confusing to be modified easily. In open-source software, postponing sending local changes to the upstream project is a technical debt. See also, bus factor, big ball of mud, bit rot, TODO, FICSM, XXX, software entropy, SQALE, references, Ward Cunningham. The WY Cache Portfolio Management System. Retrieved September 26, 2008. Karivsky, Joshua. Refactoring to Patterns. ISBN A0-321-21335-1. External links. Ward explains debt metaphor. Video from Ward Cunningham, on technical debt. The online community for discussing technical debt. Tech Debt, the first collaborative and live benchmark on technical debt and software quality. Experts interviews on technical debt. Ward Cunningham, Philippe Cructon, Ipekoskaya, Jean-Louis Leachazet, Steve McConnell discusses technical debt. Technical debt from Martin Fowler-Blakey, and Andy Lester talk entitled Get Out of Technical Debt Now. Layman's Law, Limited WIP Society website discusses techniques to avoid building up technical debt. Managing Technical Debt by Steve McConnell.